What's poppin', dogs? Mr. Allen here with an introduction to exponential and logarithmic functions and the relationship that they have with one another. So I'm going to show you guys how to go from exponential to logarithmic form, from logarithmic to exponential, and also why we even learn logarithms. They're actually super duper useful. So for this first one here, it says write it in logarithmic form. So we're going to take these. It's going to look like that. Now, I use this method called loop and swoop. It helps me organize the logarithm or organize the exponential. So I always start with my base. In this case, it's x. Then I'm going to loop around that z and land on the y. And the order in which I go is the order that we're going to see it in the logarithm. So I'm going to have log base x, that the base of the exponential is the base of the log, and vice versa. I passed by the z first, so that's the argument of the log. So whatever's in the logarithm, in that function, we call that the argument of the log. And that equals my exponent. So logarithms equal exponents. We're going to be saying that a lot throughout the logarithm unit, right? This unit is mostly about logarithms, but exponentials go along with it because we use the logs to solve for exponents. It's super awesome. All right, now let's try it with some numbers. I think it's helpful to see some numbers from time to time and actually make sense of it, and it's not just variables. So I'm going to start with my base of 2. I'm going to pass by the 8 and land on the x. So I'm going to have log base 2 of 8 equals x. Now I have a question for you. 2 to what power would equal 8? Well, 2 times 2 is 4 times 2 is 8. So 2 to the third power is 8. So I know in this one, if I were asked to solve for x, x would equal 3. Log base 2 of 8, the way we read that is 2 to what power gives me 8. That's how you evaluate a logarithm by hand. I have other videos on how to evaluate logarithms by hand. I'll link it right up here for you guys so that way you can save it for later or just kind of work through this playlist that I got going for you guys because this is the first one of many. All right, over here, we can also go go from logarithms back to exponentials. So let me grab a marker here. I'm going to start with the base, as we said before. Always start with the base. We're going to go around the answer to the logarithm and land on the argument of that logarithm. So I have b raised to the a, because that's the next thing I pass by, equals c. Boom. That is exponential form. All right, so I go between the two of them, and pending the problem that I have, I may want to be in exponential form, or I might want to be in logarithmic form. Whatever's going to help me solve the problem, or whatever it's asking me to do. Okay? The last one here, we start with our base, work our way around the 2, and land on the 9. Now check this out. We're going to see a true statement. 3, base is always the base, raised to the answer there, that's our exponent, equals the argument of the log. And I'm pretty sure we know that 3 squared is 9, okay? So always nice when it's all numbers. You're like, yes, that's true. I did that correctly. All right, a couple other things about these. Our base, we always want our base to be a positive number and also not 1. Because if it was like 1 to a power, it's just going to stay 1. So we say that is between 0 and 1 and greater than 1 for our base. And our argument of our log, the number that's in the log, always has to be positive, okay? You cannot have negative numbers as my argument of the log. But more on that later, especially as we get to solving, because we'll be dealing with things like extraneous solutions since the logs have domain restrictions. All right, but why? Why do we even care about going from exponential to logarithmic to exponential? Well, I thought you would never ask. So I have this lovely little application problem here that we're going to try to solve. It says Snoop Dogg invested $1,000 in an account earning 9.2% annual interest. When will it be worth $2,000, right? Not just after 5 years, how much is it worth? I want to know how much time it's going to take to get to that amount. Well, we've seen some equations for this before, and it would look something like this. A of t equals p times 1 plus or minus, depending if it's growing or decaying. It's growing in this case, and then raised to the t. It's a very simple type of interest formula for compounded annually. If it was compounded quarterly, daily, whatever, it'd be slightly different, but this is a pretty basic one, okay? So let's put our numbers that we know here. So I've got P is 1,000. That's what he invested, our principal, right? And then we have 9.2 as a decimal. 9.2% as a decimal is 0.092. So I'll have 1 plus that, or 1.092. That's my base, and I don't know the time, but I do know that we want it to be worth $2,000. So is there a way to figure this out? Yes. First thing I'm going to do is I'm going to divide by 1,000 on both sides here. So divide by 1,000 and divide by 1,000. And now we're going to have 2,000 divided by 1,000 is just 2, right? And then we got 1.092 t. How do I solve for t? It seems weird, right? I can't divide by 1.092. It's not this times t. It's this raised to the t. What if I wrote it in logarithmic form? Now check this out. I'm going to start with my base, and this one is, see how it's backwards? The exponent was on the left side here, now it's on the right. The loop and swoop still works the other way, so I'm going to start here, and I'm going to land on the t right there. So now what I'm going to have here is log, let me do this in a separate color, let's go green for this. Log base 1.092 of 2 equals t. So right now, if I plug this into my calculator, just like that, log base 1.092 of t, it'll tell me how long it takes, okay? And it's kind of awesome. I love log. They seem like magic, all right? So here's how you get a log any base. Because if you just hit the log key, which is to the left of the 7 there, it's going to come up like this. That's log base 10. And you can use that. It's called change of base to evaluate something like this. But there's a better way on these newer ones. If you have an 84, hit math, then the alpha button right above it, the green guy, and then math again, and check it out. I can literally type in 1.092, 2, are we ready? Drum roll, please. Hit enter. 7.876 years, so 7.9 years is what we're looking at right there, right? So my answer here, 7.9 years. And you can actually plug that back in, right? We could plug it into our equation if we really wanted. 1,000, parentheses 1.092, raised to the 7.9 years. It'll be slightly off of 2,000, right? Because we just rounded. Let's see what it is. 2004. Okay, and what if I did this? Check it out. This will be helpful for you guys going forward. You can actually copy and paste in this thing. So I'm going to arrow up. I put my exponent. I'm going to arrow up to the time that we solved for. See how the 7.875 is highlighted? Hit enter. It plugs it into the exponent. Oh my goodness. $2,000. Okay. So there we go. 7.9 years, about 7.9 years for Snoop Doggy Dogg to have his account basically double, and he'll have $2,000. So there we go, guys. That is the purpose of logarithms. It's to solve for exponents, right? That's how we use them algebraically is, oh my goodness, my variable's in the exponent. I can solve using logarithms and obviously some other algebra. And there's some other situations you guys are going to encounter along the way. I've got all of those different situations in this exponential and logarithm playlist that you are currently on. Hopefully, otherwise, head to my channel, check out the playlist because we got a ton of different scenarios that you're going to work through. If you guys have any questions, comments, concerns, suggestions for videos, or just want to say what up, pop it in the comments. Otherwise, have a great day.